lesson is entitled Predicting with Linear Models, Lesson 5.7. You should be on page 335. Now, the word predicting is important because if you remember at the end of my last video, I said when you make your line of fit and you write an equation for your line of fit, you can use that equation to predict current and future and even past results. That's what this lesson is about. It's going to show us how we use our line of fit to predict other results. Now, the line that most closely follows a trend in data is called the best fitting line. Yet on the last video in 5.6, we called that the line of best fit. So that's the same. They call it best fitting line here, but line of best fit and best fitting line mean the same thing. We practiced writing those and drawing those in our homework in 5.6. Remember, when you draw a line of best fit, you want half the points to be above that line and half to be below if there's correlation. The process of finding the best fitting line to model a set of data is called linear regression. So really, I'm kind of surprised the book didn't bring up this term in the last lesson, because what you did in lesson 5.6 is linear regression. Linear regression is you made a scatter plot, you determined what kind of correlation the line or the graph had, you drew a line of fit. That process is called linear regression. You can perform linear regression using technology. So what I have highlighted in blue is saying we can actually do that process on our calculator. I had you do it by hand in the bookwork in the last lesson. I'm going to show you how you can use your calculator to do the same process today. Using a line or its equation to approximate a value between two known values is called linear interpolation. I'll show you an example of this in a minute. It's easier to explain by showing, but interpolation means you are estimating data inside the rest of your data. If you're wondering what do you mean by that, I will show you in a minute. We're going to interpolate using an equation. In other words, interpolate, we're going to estimate data inside the other data for this problem. I'm going to show you how to do this on your calculator. Now, before we type this in our calculator, we got to make sure that we understand the years are the X's, and in this problem, the CD singles shipped in millions are the Y's. We're going to do this on our calculator right now. So please have your calculator out, because I want you to type this in as I am. Before we type this in, let's make something clear about our table. This table shows the number of CD singles shipped by millions, in millions, by manufacturers for several years during the period 1993 to 1997. So when we type this in our calculator, we're going to type in year 0, which is 1993, that's when this process starts, is 7.8 million single CDs shipped. 2 years later, it was 22 million. 3 years later, 43 million. 4 years later, 67 million. We want to type this table in our calculator. So let's do that. Let's go to our calculator. And remember, to type a table in, we're going to hit the Stat key first. Option 1 is Edit. There's a table. The first point to plug in, remember, on our table was the point 0, 7.8. So let's plug that in. 0 for X and 7.8 for Y. The next point I wanted to plug in was 2 and 22. So I'll get that in, 2 and 22. Oops, I got too much in there. There we go, 22. My next point to plug in was 343. So 3 and 43. And my last point to plug in was 4 and 67. So 4 and 67. Okay, I have my table plugged in. There we go. Next, I need to make a scatter plot of this data to see if there's a correlation. I'm going to do this on my calculator. I'm going to show you how right now. We have not done this before, so you might want to write these steps in your notes. To make a scatter plot, I already have 4 points. I want my calculator to graph these 4 points. So here's how you do that. Do you see above the y equals key where it says stat plot? I want to plot points. So hit second y equals, and you'll see a menu pop up. This is telling you you could do 4 different graphs at once on this calculator. I don't need all 4, I just need 1. So just hit option 1. Right now the graph is off. I want to turn it on, so when it's flashing on, press enter. Now arrow down to type a graph. You can see all these different kinds of graphs that you put on your calculator. You see a bar graph, you see histograms. We want a scatter plot. That's the flashing symbol right there. So just press enter. We definitely want the scatter plot. Now, the next 2 questions. Remember how we typed the x's in list 1 and the y's in list 2? The calculator is asking you, did you want list 1 to be the x's and did you want list 2 to be the y's? Yes, I did. So just scroll past that, and then they'll let you choose. Hello, Derek speaking. Yep. If I am, I guess we're just going to give them 2 freebies. Did I miss at it? There's 3, 6, 9, 12, 15 on the front page. I got 10 in that next question, 25, 28, 33. No, I got 40. Okay, ready? There's 15 on the front. That means there's got to be 25 in the back. Okay, number 6 is 10 points total. Number 7 is 3 more. Number 8 has a 3 and a 2-pointer. Yep. And then we got the, okay? Yep. When you look at this table, I have the point 2, 22, 343, and 467. There's points that are off my graph that my calculator can't show. So let's go back to that and let's look at that again. So 222, if I take my blue pen, would be somewhere way in the heck up here. I can't even see it. And 343 is off my computer screen, and so is 467. I have to change my scale for this to show up. So here's how you can change your scale so you can see those other points. Go to the window key. So hit the window key, and you'll see a window pop up. And this is saying that your x's are set to go from -10 to 10. Well, that's okay. I only had to get up to 4 for x. Remember, my x's were 0, 1, 2, 3, 4. But now let's go to the y's. My y's go from -10 up to 10. Well, my biggest y value was 67. I at least have to get up to 70 to see everything. So let's change our y scale from -10 to 10 to -10 to 70. And now hit graph one more time. Oh, there are my points. Now I can see my scatter plot. Now here's the next thing. Does this have a correlation? I think so. It looks like this is positive. Okay, so now here's the next thing. We want our calculator to draw this line of fit and to do the linear regression for us. Remember in the last video I showed you how you can put 2 points on your line calculate the slope, and then in point slope change that into slope-intercept form, and you had a line, my calculator will do that all for me. Here's how you do it. Go back to the stat key. Remember, we already have stats typed in. If I hit option 1, I'll see that table I already made on my calculator. Go to calculate. We want a linear regression. Do you see option 4 is linear regression? This will give me the equation that the line of best fit is producing from these points. So go down to option 4, press enter, and if you have the older calculator, you're just going to press enter again. If you have a newer calculator, you'll have to scroll down to calculate, I believe, and press enter. There's the line of best fit. Let me write this line of best fit on this slide. It's about y equals, we're going to estimate it to 14.5x plus 2.43, and I should put about equals. It's not exactly. I'm going to put the wavy equal. That's about my equation for my line of best fit. So let's remember that equation, type it in our calculator, and we'll draw the line of best fit. So it's 14.5x plus 2.43. So let's go to the y equals key and type in 14.5x plus 2.43, and then go ahead and press graph, and look what my calculator does. It just drew the line of best fit for me. So that looks like the line of best fit. Y equals 14.5 plus 2.43. You can see it on the calculator. So let's go back to our textbook now. And you can see in the book, we did a better job of estimating this than the book did. We said y equaled, or it was about, 14.5x plus 2.43. Do you see how close that is to what they have? Okay, now here's the next thing. So we got the equation on our calculator. We haven't had to do any work on paper. Now I want to approximate the number of CD singles shipped in 1994. Now you notice they didn't show that on my table. 1994 is year 1. Do you notice how year 1 is inside the rest of the data? Because it's inside the data, that's called interpolation. We are going to estimate data inside the rest of our data. So here's all you got to do. You take 1, you put it in here for X, and this will give an estimation of about how many CDs we shipped. So it would be 14.5 times 1 plus 2.43. Let me put that in my calculator real quick. And when I do that, and I hope you did as well, you're getting 16.93 million CDs sold. That's our estimation of the number of CDs sold in 1994. They said about 16 million. We have about a little bit closer to 17. Again, this is an estimation. Interpolation is estimating. Now, extrapolation is the exact same process with one exception. When you do your estimation, you are using your line to approximate a value outside the rest of the data. That's called extrapolation. So we don't have to do the entire problem again, but let's now extrapolate something from that past problem. So here would be extrapolation. Let's say that I wanted to estimate how many CDs were sold in the year 2010 based on my equation. Okay, now 2010 is 17 years after 1993. Correct? 17 years later? If you take 17 and plug it in here, let's do that. So I'm going to take 14.5 times 17 plus 2.43. I'm getting about, well, almost 249 million CDs sold. I just extrapolated. Do you notice how 2010 is outside the rest of that data? It's not inside, it's outside. That's called extrapolation. So extrapolation, it's the same process, it's just you're estimating a point outside the data. In other words, when the book was made, I was predicting the future. 2010 would have been the future of this data. I'm making a future prediction of CDs sold based on my equation. It's important to understand that the farther removed an X value is from the known X values, the less confidence you can have in the accuracy of your predicted Y value. Okay, so in those prior two examples, when I estimated 1994, remember, was inside the rest of my data. So I can be, take a highlighter, I can be pretty certain that this number is fairly accurate, about 17 million. That's probably accurate because it's inside the rest of the data. Okay? But my 2010 prediction is way outside the rest of the data. I can't, with a T, I can't be as certain about the number 249 million. I should have wrote million in there. Million CDs sold, because that's so far in the future. It's 17 years in the future. I can't be as guaranteed of the accuracy of that number. That's what I just highlighted is showing you. Let's do a problem here without our calculator, just because, again, on the test, I could have you do it with your calculator or without. We are going to make a scatter plot of this data, find a line of fit, and then make some predictions based on that. So they give me the year. The years are the X's. So let me write that in there. And the median floor area, of course, that's the Y's. So let me highlight that. Here are my Y's. And I want to graph this. So let's go to graph paper and graph it. Now, when I do this, this is for new single-family houses in the United States during the period 1995 to 1999. So when I graph, this is going to be year 0, year 1, year 2, year 3, and year 4. So let's start graphing those points then. Now, the first thing I notice before I start graphing, my first point is 0, 1920. 1920 is going to fly off my graph paper. I have to pick a different scale. So what I think I'm going to do to make this fit nice, I'm going to skip my scale up to 1900, and I'll go by, I think I can go probably by tens beyond that. So this is 1910, 1920, 1930, 1940, 1950. Let me do that, finish. And just so you weren't having to wait on the video, I wrote in the square footage for Y in the years since 1995. Okay, so let's start plotting. Year 0, it was the point 1920, which would be here. 1 year later, we were up to 1950. 2 years later, we were at 1975. 3 years later, we were at the year 2000, we're at the square footage 2000. And 4 years later, we were at 2028, which would be here. And it looks to, well, you can see there's definitely a positive correlation. So let's take my ruler out. I'm going to try to draw a line of best fit as best I can through that. I'm just trying to eye it up. Let me try that again. I'm trying to get a good line of best fit here. That's not too bad right there. Okay, now I have to write my equation. So let's pick 2 points on this line. So I'm going to pick the point. It looks like my line is at 0 and 1922 maybe, and this looks perfect, 2000. Okay, so let me get my slope. It would be 2000 minus 1922 over 3 minus 0. And that would be 78 over 3, which would equal, if I'm doing my mental math right, that's 26. My slope is 26, and my y-intercept, B, would be 1922, So my equation is y equals 26x plus 1922. There's my equation for my line of best fit. Now, after I have that, they want me to predict the median floor area in the year 2000 and in 2001. So let's do that. Year 2000 is year 5. So let's go ahead and plug 5 in here. 26 times 5 plus 1922 would give me the answer to this. So take your calculator and do that. 26 times 5 plus 1922. That would be 2,052 square feet. That's my 2010 square footage, or my year 2000 square footage prediction. 2001 would be year 6. So put a 6 in for x, and let's predict what the square footage would be in 2001. 26 times 6 plus 1922. I'm predicting 2,078 square feet. Now the next question, which prediction do I think would be more accurate? It's going to have to be 2000 because 2000 is the year that is closer to the rest of my data. You notice my data only goes from here to here. My data only goes from 1995 to 1999. 2000's closer, so I would expect 2000's estimate to be more accurate than 2001. And then, I'm sorry the video's long. To wrap things up, we have one more quick thing to talk about, the zero of a function. We've already talked about this some this year. A zero of a function is an x value for which f of x would equal 0. So if you want to find the zero of a function, here would be an example right here of that process. Let's say we had f of x equals 2x minus 4, and I want to find the zero of a function. I want to find out what number can I plug in for x to make this 0. So take f of x and replace it with 0. Okay? So I'm going to do that off to the side. Instead of having f of x, I wrote a 0 in there. 2x minus 4 would equal 0. I got to now onion the x to figure out what that is. So add 4, divide by 2. 2 would be the 0 of the function. In other words, think about it. If you plug a 2 in here, let's calculate it. 2 times 2 is 4. 4 minus 4 is 0. Plugging in 2 makes this work out to 0. So 2 is the 0 of this function. I'm going to stop the video here. If you have questions, make sure you ask during class.